Good morning, students. Today's class we will see about finders algorithm. So finders algorithm, yeah, finders algorithm we will see. Finders algorithm is called maximally finding a maximally specific hypothesis. So in this finders algorithm, we will find the maximally specific hypothesis. So here what we do is the thing is how can we more generalize the partial or ordering of your data sets. So whenever the data set is given, we will observe the training example and we will classify only the positive instances. In finders algorithm we cannot classify the negative instances. So the what we do here is the first thing is we will initialize the hypothesis to most specific, and then we will try to generalize for each instances. We will try to classify our algorithm, and from most specific hypothesis to we will try to generalize so that all positive data sets can be classified. So here we have taken the enjoy sports classified data example. You can observe that there are six attributes and enjoy sports is our target concept. So sky, air temperature, humidity, wind, water and forecast. There are six attributes. The possible values of the sky is sunny and rainy. The possible values of the air temperature is warm and cold. The possible values of the humidity is normal and high. The possible values of wind is strong and weak, and possible values of water is warm and cool. The forecast is same and change. And enjoy sports is whether for each instances you can observe that whether he can enjoy the sports on that day or not. For example, for the first instances, we can see that if it is sunny, warm, normal, strong, warm, same. When the sky is sunny, the air temperature is warm and the humidity is normal and the wind is strong and water is warm and forecast is same, he can enjoy the sports. This is how the data set is classified. Now we will go through the algorithm. Initialize H to the most specific hypothesis in H. So what we do is we will try to initialize our hypothesis to most specific. Most specific in the sense all are pi values. Then what we do is for each positive training instances X, so for each data sets, for each instances X, if you take it, so for each attribute constraints AI in H, for each constraint for each value we will check it out whether if it is satisfied by X or not. If it is satisfied, then we will do nothing. If it is not satisfied, the values are changed. Most specific is pi value. There are three values can be accepted. One is the pi value where no value is accepted, and most general values means all the possible values is accepted, that is represented by question mark. And uh, the particular we have solved it. So the same data set we have taken here. So initialize H to most specific hypothesis in H. So our most specific hypothesis H is initialized to all pi values. There are six attributes, six pi values. For each positive instances X, for each attribute AI in H, if the constraint AI is satisfied by X, then do nothing else, replace. So the first instances we have taken, you can observe here. The first instance is if we can observe here, the first instances here is sunny, warm, normal, strong, warm, same with positive examples. So the first instance we have taken here. So A1, A2, A3, A4, A5, A6. So instead of assigning most specific, some values can be accepted. So what we do is the hypothesis we will replace with the first instances. So the iteration 2, the next instances we will consider, that is sunny, warm, normal, strong, warm, same. Here what we do is we will check with R. The second instance is sunny, warm, high, strong, warm, same with positive data set. The, then what we do is we will consider the hypothesis 1. The hypothesis 1 and the instances X we will check it. So listen, sunny and sunny both the values are matching, we will retain the same thing. Warm and warm is matching, we will retain the same thing. And here you can observe that normal and high, here you can observe that normal and high, these values are not matching. So what we do is we will just put it with your question mark. We will just replace with our question mark. Then strong and strong is same, same we will replace. Warm and warm, same we will replace. Same and same is same we will replace. And the third iteration is negative. The third iteration is negative. X3 is negative. You can observe here in our data set. X3 it is rainy, cold, high, strong, warm and change. No, no means it is negative. So what we do is in that case we will just retain the previous hypothesis. That is H2 is equal to H3. Now H4 instances is sunny, warm, high, strong, cool and change. So we will compare with H3 instances. Already this is generalized, so we will keep it same. So the first value is sunny and sunny, we will retain same. Second value is warm and warm, we will retain same. Third value is high and high and sunny, we will retain same. This is already question mark, so we will try to generalize it. Strong and strong, we will retain same. Warm and cool, same. Both values are this match. Question marks accepted either high or low, either warm or cool, either same or change. Both the values are accepted in the case. If both the values is accepted, he can play the tennis. This is our hypothesis. So in this case, what we do is how to match our hypothesis. You can observe here. You can observe here. See the instances X, the hypothesis H. What we will write hypothesis H0, H1, H2, H3, H4. So here the instances x1, x2, x3, x4. So consider x1. X1 can be mapped to your H1. H0 cannot be mapped to any of the instances as it is most specific. From from H1 we can derive H0. So that is why the mark is going this H1 we have derived. So H1 can is H1 hypothesis is classified under X1 instances. X1. So H2 and H3 are same. So it is done with your X2 and x3. So you can observe that x1 is under x2 instances. So if I classify h2, from h2 I can derive h1 and h0. So that is why we have put it in one circle. So the next is x4. From x4 is out, but x1 is x. From x4 instances or from h4 hypothesis we can derive h2, h3, H1, H2, H3 also. So that is why this is from specific to generalized one. You can observe here. This is how we can classify, we can represent it in diagrammatically. So the next example we can see here is the next example we will see the number of citation size in library price editions and by. So it is of book databases. If the citation is some many citations may be there, the size is small or big, medium are there in libraries, available in libraries always or no. If the price is affordable or expensive, the edition is one, few, many, and by. This is our target concept. It is yes or no. How many concepts are possible for this instance space? How many hypotheses can be expressed by an hypothesis language? Apply finder's algorithm by hand on a given training set. Consider the example in a specified order and write down your hypothesis each time in observed data. So citations means how many citations possible. The first answer is how many concepts are possible for the instance space. You can observe that for the citation there are two values, some and many. For the size, there are three values: small, big, and medium. In library, there are two values: always and no. For the price, you can observe that it is affordable and expensive. Edition is one, many, few. Three values is accepted. So there are five attributes. So citation, how many values? Two. Size, how many values? Small, big, and medium. Library, how many values? No and always. Price is affordable and expensive. Edition is one or many. So the number of possible concepts is if we multiply all the things, we'll get 72. The second question is how many hypotheses can be expressed by hypothesis language. So here, apart from the possible concepts, there are two concepts which can be accepted, either null and question mark. And you can observe here that we can generalize it. Either null values can be accepted and question mark. But in our data set, there is no null values accepted. But for every data set, there are two values accepted. So we will calculate it with, so you can observe that two values plus two you have to add for each concept. So 2 plus 2, 3 plus 2, like if you do 1006 hypotheses are possible for a given data set. But here there is no null value, so we will eliminate one. Instead of adding two, we will add only one. So if you add semantically distinct hypothesis, we call it as, if there is no null values, we call it as semantically distinct hypothesis. So here 3 into 4 into 3 into 3 into 4 plus 1. We will consider the overall will apply finder's algorithm. Initially, we will initialize with the most specific hypothesis. There are five attributes of five hypotheses we have initialized. So first in is name. Match with our H4 hypothesis. Main and mini as we will retain that as question mark and question mark. This is how the finder's algorithm works. And next is the key properties of finder's algorithm. Finder's